Certain isotopes are unstable, and this might be because they've got too many neutrons relative to the protons. It might just be because the nucleus itself is so big. Unstable isotopes are prone to decay. Decay just means that something in the nucleus is going to change, and that usually changes the element itself. So the nucleus will change, and when that happens, we have nuclear radiation emitted from the nucleus as well. Now, there are three types of nuclear radiation. There's alpha, beta, and gamma. So let's go through some properties of each one of those. Alpha radiation is a particle made of 2 protons and 2 neutrons. Now remember that protons and neutrons both have a relative mass of 1. So 2 protons, 2 neutrons, that means this alpha particle is going to have a relative mass of 4. What about charge? Well, protons have a charge of +1, neutrons have no charge. So 2 protons, that means it's going to have a charge of +2. Now, because these particles are so big, they are highly ionizing, which means it's quite harmful. However, it's not very penetrating. It can't travel very far. It can only go a couple of centimeters through air before being stopped, and it can be stopped easily by things like paper or skin. Beta radiation is a fast-moving electron. So if it's an electron, that means it's got a charge of -1 and it's got a negligible mass, about 1/2000th of a proton or a neutron. Now, it's moderately ionizing, not quite as ionizing as alpha, but it can travel quite a bit further than alpha. It's a lot more penetrating. It can go about 1 meter through air, and if you want to stop it, you'll need a thin bit of aluminium or something. It can go straight through paper and skin. Gamma radiation isn't a particle at all. It's a high energy electromagnetic wave. That means it has no charge and it has no mass. It's not very ionizing, much less than alpha and beta, but it's extremely penetrating. It can go through air pretty much indefinitely, and if you want to stop it, you'll need a thick bit of lead, and even then, some of it will probably get through. So there you have it, the basics of nuclear radiation, as easy as alpha, beta, gamma.